Hello friends, welcome to my channel. Let's have a look at problem 28. Find the index of the first occurrence in a string. In this video, we're going to share a treatment based on encoding or hashing. So this treatment is similar to the Rabin-Karp string matching algorithm, but in a simplified fashion. First, I'll read through the problem statement, and then we look at the analysis, and finally we share the code. So also we need to notice that this problem can be solved in a brute force way. We also comment or share the code for that kind of solution. Now let's look at the problem statement. So given two strings, needle and haystack, return the index of the first occurrence of needle in haystack, or -1 if needle is not part of the haystack. So here are two examples. So both the two examples are very special. So example 1, actually, the output is -1 because a needle does not appear in the haystack. So in the first example, the needle is SAD. So the SAD actually is a prefix for haystack in this example, right? So we're going to look at another example based on example 1 when we do the analysis. So before we do the analysis, let's also look at the constraints. First, the two strings are non-empty and the length is bounded above by 10 to the power 4. Secondly, the two strings consist of only lowercase English letters. So notice that there are only 26 lowercase English characters. So with that said, we are ready to do the analysis. So as we mentioned, so we are going to use encoding or hashing. So actually, for this problem, we can design the encoding or hashing very easily. So if you are interested, you can check out the Rabin-Karp string matching algorithm. So this is a well-known algorithm. So here the idea is the following. So we need to encode information about the character and the locations it appears in needle, and then do comparison when we scan the haystack. So the consideration here is how to do the comparison economically during sliding window. So in this video, I'm going to use a hashing based on base n algorithm. So here n is 26 because 26 is the number of lowercase English letters. So I'm going to use example 1 to fix the idea. So here the haystack is this string, but I changed needle to be but because but appears in the middle. And then we're going to consider the map. So we're going to see A is the corresponding to 0 and B corresponding to 1, therefore Z corresponding to 25. And then for the needle, we hash it to an integer as below. So what we're going to do is that, so we use this character corresponding to the number. So this is the 1. Then we multiply this one by a power. The power is 26 to the power I. So I is the position of this character in the needle, right? So with this hashing, actually, we include both character information and position information. So for example, in this example for but, so because B corresponding to 1 and it appears at index 0, so it corresponds to this number, 1 times 26 to the power 0. So similarly, U corresponds to the character 20. So we have 20 times a power. It's because U appears at index 1, so it corresponds to 26 to the power 1. So similarly, T corresponds to 19 here. So we have 19. So here times a power, that is 26 to the power 2, because T appears at index 2. So this is the result. This is an integer number. And then we just need to compare if the hash of the segments in the haystack equals the hash of the needle. If so, we find the corresponding index. But here the question is how to do comparison when we do sliding window. So we can do in a brute force way, but we need to do it in a more economical way. So here we check the hash for the beginning segment. For example, SAD. That's the beginning, the same length as the needle. So we have S corresponding to 8, then s at position 0, so we get this part. So similarly, you can add other parts. You get 20, 46. So this 2 does not equal, so we continue. So now we move to the next slide, that is ADB, right? So we add a B, then pop S. So in order to get this, we do the following, right? So the relation between the hash of SAD and ADB is the inclusion of B and exclusion of A, right? So at the base of the hash for the set, then we add the part for B, but here we raise to the power 3. Then, because 3 is actually the length, the larger by 1 than the length of needle. And then we delete that part corresponding to S, right? Because S appears at 0, so we get this one. But this way, we need to divide by 26, because we need the powers to be 0, 1, 2, right? But here, this expression, the powers of 26 is 1, 2, 3, right? So we divide by 26. Then we get 754. Then it's still not equal, so we continue. So we continue this fashion. When we slide towards the right in haystack, we just need to do 3 operations. So plus here, minus here, and division into division here. So we do not need to do a for loop that equals to the length of the needle. So that's the main idea for this problem. So now we can actually write the code corresponding to the above walkthrough. So before we do that, let's first notice that this problem can also be solved in a brute force fashion. It's just a brute force comparison and use a for loop, but that's not very economical, right? So now let's first write the solution corresponds to our walkthrough, and then we also share the code for the brute force solution. So for convenience, I'm going to use some imports. So I want to get A, B, C, D up to Z, right? So from a string, so we can import ASCII lowercase. So I can give it a name. Let's call it characters. These are the lowercase characters. So you can print out that just for check. So let's see. I'll return -1. So we get A, B, C, D up to Z, right? So now with that said, confirmed, so we can first make a dictionary to get the characters and the corresponding numbers. So for I, character in enumerate characters. So this is a dictionary comprehension. So next, I'm going to get the length of the needle and the length of the haystack. It's supposed to be the situation that m is less than or equal to n. So first, let's check an edge case. If n is less than m, so we are going to return -1, because there's no match for sure. Next, first I want to get the encoding or hashing for the needle. I'll call it ref. So yeah, actually we can use list comprehension like here, or I just use a for loop. Let's use a for loop. For I character in enumerate needle. So here I'm using a for loop. It's just for the demonstration purpose. So we can change this for loop to be a list comprehension or iterate, something like that. So then we get this d character. This is number, then times 26 raised to the power of the position, right? So this gives us the the hashing value for the needle. And then also let's first get the hashing for the segment in the haystack, and then we move do the sliding window. So here let's do this for I in range m. So we just need this length, and then let's write more lines just for clarity. So we get the corresponding character in haystack. That is character. This is I. Then what we are going to do is to add this part, right? And then encoding the position. So this gives us the starting piece, the hashing value. Then we need to compare it. If start equals ref, then we are going to return 0 in this case. And now let's do the sliding window, right? So for I in range, so from M to M, right? So we are going to include the character at index I and exclude the beginning character, that is character at index I minus M in the haystack. So what we're going to do is first get current character. The current character is haystack I. The character to pop, character is haystack I minus M, right? So what we are going to do is at the base of the previous start status. So we're going to do some add. So we add the character, then add times the power. So let's first choose the power to be the length of this haystack. That is the position plus 1. And then we're going to do minus. So we're going to minus the character pop. Then actually it's to the power 36. Then raised to the power 0, right? So this is 1, but I'm going to write in this format to make the idea clear. And then what we're going to do is to do the integer division by 26. So this way we get the hashing value for the next piece of segments. Then what we're going to do is a comparison, right? If start equals reference, then we're going to return the index. So notice that this piece is ending at index I. So the starting index will be I minus M plus 1. So this plus 1 is important. So if after this for loop nothing has returned, so we need to return -1. So this piece of code actually forms a full solution format for this classic problem. So before we do any comments, let's first do a check. Yeah, it passes the first example. Now let's look at, let's modify that to be the first example exactly. So that is SAD, right? So yeah, it works. Now let's look at generic case. Yeah, it passes all the test cases fast. So I guess that's one solution format. But you know, for this problem, if you like, so actually you can do a brute force solution. So here, let me make a remark. So here is hashing or Rabin-Karp method. So now let me copy this part, and then I'll change this one to be version v1. So now let's look at a brute force solution. So for this brute force solution, so we just brute force. So we directly compare, right? So first let's get mn equals the length of needle and the length of haystack. Then what we are going to do is we use a for loop for I in range. And because there's m and n, there are supposed to be n minus m plus 1 length m segment out of this n, right? So let's get the segment that is haystack. So I from I plus m. So this is the length m segment. Then we compare segment with respect to the needle directly or in a brute force way. So if they are the same, so we're going to return I. Otherwise, we're going to return -1 out of this for loop. So this actually seems very easy to understand in logically, but the term complexity is slightly larger than this first solution. So because we use for loop when we compare, but here actually for the comparison we do not use for loop of length equal being the length of the needle. So let's also do a check. So we have changed this function name. So when we check, we are checking this one. Yeah, it passes, but it's slow, right? So I guess with these two formats of solutions presented, so we are emphasizing the version 1 here based on hashing or encoding. So you are actually you are welcome to try other hashing or encoding method for this problem. So with that said, I guess that's about it for this specific problem and this video. Thank you.